Welcome to Cole's World of Mathematics, where math is made simple and clear.
In these couple of examples here, we're going to talk about when it's appropriate to factor out a negative and when it is not necessary. All right, in this first example right here, I have a trinomial. I have the leading coefficient is negative. All right, now let's say it's got a greatest common factor, which it does. It's going to be 2. If I just take out a positive 2, then that leaves a negative in front of that x squared, which would make factoring the trinomial difficult. So when your leading coefficient is negative, that's when we are definitely going to factor out a negative. So on this one, we're going to take out a negative 2. So we're going to pull that negative 2 out in front. What that's going to do, it's going to change all the signs. That's going to give us a leading positive x squared now on that inside. And then it'll change all the signs, so that'll go to a plus 2x, and then that's going to go to a minus 24. Now what that does is that makes it easy for us to now take what's on the inside right here and continue to factor, if possible. And in this one, yes, we can. So that negative 2 carries down. It's a trinomial, leading coefficient of 1. So we'll have an x and an x. And then again, you're going to go through those factors of 24, 1 and 24, 2 and 12, until you come up with the fact that 6 times 4 is 24, and that's what's going to get us that middle term. You're going to have the 6 and the 4. Because the 2x is positive in front, I'm going to need a plus sign on the 6 and the minus sign on the 4. Okay, so then there is when and why you would want to factor out a negative. Now, over here on this second example, you got a perfect square root of 25, you got a perfect square root of 9x squared minus sign. So yes, this is definitely the difference of two squares. All right, there is no reason to factor out a negative. Now, I know why people want to. It's because generally in most textbooks, and when we originally teach the difference of two squares, what do? We almost always give you like x squared minus 9. We make that x squared term first and then the 9 second. And so that kind of trains you to do, x plus 3, x minus 3. And what that leads as a misconception is that the x term has to be first. All right, that is not the case. It's just that when we teach the difference of two squares, more times than not in a textbook, they always put that x squared term in the front, which then leads you to think that. All right, however, over here, that's still a perfect square. This is still a perfect square. I'm going to read this left to right, and when I write the two binomials, one with a plus sign, one with a minus sign, I have to do it in the exact order that it's given to me. Okay, so in this one then, square root of 25 is 5. That square root of the 9x squared is going to be 3x squared. So I'm just going to have a 5 plus 3x and then a 5 minus 3x. All right, and there's nothing wrong with that. That is perfectly fine. If the x term happens to be the second one, then when you factor that difference of two squares, your x term just happens to be the second term there. All right, but no reason whatsoever to factor out a negative there, so we don't want to do it. So two quick examples there, when it's appropriate to factor out a negative and when you should not factor out a negative.